Hello grade 7s. Today in math we are looking at using formulas. So I've introduced those a little bit to you because we've been looking at finding out the area of a triangle and a parallelogram, and now we're going to look at just why do we use formulas and how can we use them in lots of different situations. So before I start, I just want to point out Eva's name here and Matthew's name. Good job, Eva and Matthew, on doing your homework. So you are our people of the day. Okay, so before we talk about why do we use formulas, let's talk for a minute about what is a formula. So a formula is basically an equation which shows the relationship between two or more things. So an equation is just a mathematical sentence. So in math we use sentences that use numbers instead of words. And so this sentence just shows how do two different things or more relate to one another. Okay, so why do we use them? Well, it just saves us a lot of time. So instead of coming to a problem and thinking, oh, what do I do? How do I find out the area of a triangle? And then you're having to do a lot of mathematical proofs and reinventing the wheel every time, the way that mathematicians did to find out the formula. Instead of doing all of that, you can just use the formula that others have found out for you, and you can plug that in, put your numbers in, and you can get your answer pretty quickly. So we use formulas with money and with paying bills and cooking and computers and science and engineering. So there's people that use a lot of formulas every day. Not everyone uses as many as other people, but we all use formulas to some extent. I'll give you an example of something. I made up a formula this week because I was baking bread, and I had something called rapid yeast, and my recipe wanted me to use active yeast. So I looked up online, can you just substitute them one for another? But with rapid yeast, you needed less than with active yeast. And what I found out was that if a recipe called for rapid yeast, you should use 1¼ times more of active. But I had the opposite problem. So I had to figure that out and do the math and come up with my own formula, which is that 4/5 of active yeast is equal to blank of rapid yeast. So then I could use that formula, and for whatever recipe of bread that I chose, then I could just plug that in and do that. And now that I have that formula, that will be helpful for me as I continue to make bread as we stay home and don't go to the grocery store so often. Okay, so that's a little bit of what are formulas and why do we use them and when do we use them. Now let's look at how do you use a formula. So if you have a problem, this is the case with any kind of word problem or any kind of mathematical problem that you are faced with. What you have to think about first of all is not what you don't know. You want to think about what do you know. Because if you think about what you don't know, you're going to get too discouraged. That's one thing. And you are just going to only see the problem. You have to think about, okay, well, what kind of resources do I have? And that's a good life tip for any situation you find yourself in. What do I know? What do I have that could help me? What can I use here? Or what have I learned in the past? That's helpful for any kind of situation you find yourself in. Okay, so what you do is you circle what you know. And you just want to highlight those things. Okay, well, I know these things. I don't know everything, but I do know some things. And then you underline what you don't know or what you want to find out. Then you'll draw a sketch. So a sketch is you don't want to take a long time drawing your picture, but you want to just quickly draw a little picture so you can envision what it is you're thinking about. And then you're going to choose what formula are you using. So what kind of problem is this? Is this a circle that we're looking at? Is it a square? What's going on? And then that will help you choose what formula to use, because depending on what problem it is, you'll use a different formula to find out your answer. Okay, so I'm going to go through 3 or 4 problems with you here, just to give you a sense of how do you do this type of problem, and then I'll tell you what you guys are going to do in your book for today. Okay. Okay, so for number 1, let's say you are told that you have a parallelogram and that the base is 6 meters, and the height is 7 meters. Okay, so let's draw a little sketch. So the base is 6 meters and the height's a little bit longer than it. So, that's not very good. So it doesn't have to be perfect, but we do want to have it somewhat accurate. So 6 meters and 7 meters. So we've, oops, I went and did our sketch too quickly. Let's go through our steps here. So what we want to do is we want to underline circle, what do we know? Well, we know it's a parallelogram. We know the base is 6 meters and we know the height is 7 meters. And we want to find out what is the area. So we'll underline area because we don't know what the area is, but we do know a lot of other things. So we draw our sketch and then we decide what kind of formula do we want to use. So let's see. So it's parallelogram, we want to find the area. So the area is what? Now if this was a triangle, it would be base times height divided by 2. If it was a square, it would be length times width. But it's a parallelogram, so it's base times height. Now we know what our base is, that's 6, and our height is 7. So we multiply those together, and then we write our units down. Oops, not centimeters, meters. 42 meters squared. So we found our answer. Okay, let me run through another question with you. Okay, so let's say B, we have a desk and it's 1 meter deep and 120 centimeters wide. What is the area? Okay, so let's go through our 4 steps. For the first step, what do we know? We know it's a desk. So then you can think, what sort of desk, what kind of shape is that? Generally, that would be a rectangle. Okay, we know that it's 1 meter deep and 120 centimeters wide. And then number 2, what do we not know, or what are we looking to find out? We want to know what is the area. So now let's draw a sketch. Okay, so we have our lovely desk here with our legs. Okay, so it is 120 centimeters wide and 1 meter deep. Now, do you see a problem here? We are using 2 different types of units. Now we can't, we have to have the same kind of units, or that's not going to mean anything. So if you remember, it takes 100 centimeters to make 1 meter. So let's convert 120 centimeters into meters. So we're going to move the decimal over 2 places. So we'll have 1.2 meters. Okay. And now for our 4th step, we're going to think, what sort of problem is this? What are we doing here? Well, it's a rectangle and we want to find the area. So now we need to find our formula for area of a rectangle, which is length times width. And that is 1 times 1.2, multiply that, 1.2 meters squared. So we found our area. Okay, I'm going to try another one for you here. Okay, and I just want to point out, as always, as I'm doing these problems, feel free to pause or fast forward if you're understanding. You can go a little quicker if you want to, but you can also pause and attempt to do these problems as I'm going. So once I set up the problem, you pause it and think, well, what should I do next? Because it's very easy to watch and follow along and think, oh yeah, that makes sense, but then it's not as easy to actually do it yourself. So why don't you try this on paper for yourself, or even just out loud as I'm going. Tell me what I should be doing, kind of like you would do if you were watching Dora. Okay. So see, let's say we have a flag. We want to make a flag, and a flag needs to be 1 meter long and 80 centimeters wide. Okay, and how much cloth do we need? Okay, so let's look at this. So what is our first step here? Well, we are going to circle what we know. We know it's a flag, which means that's a rectangle. We know it's 1 meter long, 80 centimeters wide. Okay, number 2, what do we not know that we would like to find out? We want to know how much cloth. This is a real problem if you were making something and you knew how big it should be or how long and how wide, but you don't know how much cloth you need. You need to find that out before you go to the fabric store because you don't want to waste your money. Fabric is very expensive. You don't want to waste your money buying too much, and you really don't want to waste your money buying too little, and then it's useless, and then you have to go back and buy more. So let's find out exactly what you need, and then you'll buy a little bit extra in case you make a mistake. Okay, so let's draw our sketch here. Our beautiful flag. Okay. Now it is 1 meter long and then 80 centimeters wide. And we have the same problem here where we're using centimeters and meters. So let's convert these to meters, and we'll move our decimal in 2 spots because it takes 100 centimeters to make 1 meter, and we don't quite have a whole meter. So this is going to be 0.8 meters. And then we have to think on our 4th step, what do we do now? Now we have to decide what sort of problem is this and what formula do we use to find this out. So we know it's a rectangle and we know the sides. We want to know how much cloth that is. Basically what they're asking is, what is the area of this flag? So then we think, well, area equals what? For a rectangle, it's length times width. So our length is 1 meter and our width is 0.8. So that's 0.8 meters squared. So that's how much cloth we're going to get. We're going to get 0.8 meters squared of cloth. Okay. All right. Let's see. Okay, this video is getting a little long. So I'm going to tell you what your homework is, and if you want to keep watching, I'll do one more example, but you could also just stop if you think you've got it and you'd like to get on to your work. Okay, so for homework, what you're going to do is page 176 and 177, numbers 1, 2, 3, and 4B. Okay? So please email me if you have questions and I can help you out. So feel free to stop watching and I'll go over one more problem for those of you that would like to watch. Okay, so D. So let's say you have a chevron, which is 2 parallelograms. And they share a base of 10 centimeters, and the height is 5 centimeters each. Okay, what is the total area? Okay, so again, what we're going to do is we're going to circle what we know. So we know that there's 2 parallelograms. Did I spell that wrong? Parallel. Oh dear. Parallelograms. Okay. We know that there's 2 parallelograms. We know that the base is 10 centimeters, and we know that the height is 5 centimeters each. Okay, what do we not know? We don't know what is the area. So let's go to the 3rd step, which is make a sketch. So 2 parallelograms. So that looks like this. Oh, I think I'm doing this backwards. Well, I'll just do it above here. Is that right? This does not look right to me. Okay. Okay, that's not exactly right, but that's the idea. Okay, so we have our sketch. Now let's label it. So it has a common base of 10 centimeters. So that's this one in here. So this is 10 across there. And they're each 5 centimeters high. So say 5 and 5. Now we want to find the total area. So what we can do, we know the formula for a parallelogram, now there's 2 of those. So we just have to double that. Or we could find each of them and add them together. Either way is fine. So the area of a parallelogram is base times height. And so let's find one of those. So the base is 10 times 5, which is 50. And we could do that again and we would get 50. So we could say 50 plus 50 is 100. But I'm just going to multiply this by 2. Times 2 is 100 centimeters squared. So we would have our area of the chevron. Okay, so we've gone over the 4 steps. Circle what you know, underline what you don't know and what you want to find out, draw a sketch, and then figure out what sort of problem it is and what kind of formula you can use to find the answer. So great, I hope things go well for you, and let me know if you need any help. Have a great day.